See here in this problem. Here, for a system having the input x of t and output is y of t. So let this is a system. So for the system, input is given as x of t, our output is given as y of t. So and it was represented with a differential equation, that is 8 into dy of t by dt plus 3 into y of t equal to 3 into derivative of x of t plus 7 into x of t. So then how can you find the transfer function for the given system? So here for input and output, the relation is given as differential equation. So first of all, consider that this is the equation 1. But we know that transfer function means it gives relation between for input and output in terms of frequency domain. So that is y of s by x of s. This ratio is called as a transfer function. But here we want the transfer function from the differential equation. So for this equation 1, apply the Laplace transform. So then we'll get 8 into, so Laplace transform of derivative of y of t is s into y of s plus 3 into Laplace transform of for y of t is y of s, thus equal to 3 into Laplace transform for derivative of x of t is s into x of s plus 7 into Laplace transform for x of t is x of s. So on left hand side, bring y of s term common. So the equation becomes y of s into 8s plus 3 equal to, bring x of s common on right hand side, that is x of s into 3s plus 7. Now bring this term on left hand side and this term on right hand side. So the equation becomes y of s divided by x of s equal to 3s plus 7 divided by 8s plus 3. So it is nothing but a transfer function for the given system, and this is the process of simplification. And thanks for watching. Please subscribe, like, share. Thanks.